This engine was designed in a hope to better harness the energy input to the system. Stirling engines are typically very efficient, however some input heat is still lost to the surroundings. Cogeneration captures that waste heat in hopes of using it for something useful. This engine demonstrates our attempt at harnessing as much heat as possible. The waste heat from the engine is used to heat up water flowing through a copper tube wrapped around the top of the engine. On a larger scale, this could be employed as a household preheater, taking away some of the stress from the actual water heater. To follow all the constraints, the design was under $30 and built out of mainly recyclable materials.
Here you can see the design of our initial system. The initial system was a lot larger, with covering from an old keg can with a side elbow up to a crankshaft, spinning the turbine. We also have this side piece which was going to shoot pressurized air through and create a sound. Now that sound would be trapped through a piezoelectrical device and converted into energy, usable energy. Since we did not have the capabilities of building a device like this, we deemed it unusable and went to a different form of capturing energy. Here's the internals of our original design. Again, you can see the side elbow, which the crankshaft will be located up here, and the basic outline of the device. Also, you can see in this one the cogeneration part, which is copper coils wrapped around above the piston to capture the waste heat. Also, you can see the candle where it will be located, or a heat source to be determined. And also, you can still see the side part, which was the pressurized air. We decided that this design was too big and we need to lower it so we could lower the heat intake to our system. And our output of what our design actually was actually a lot different from this design, but the basic concepts are still the same. Here's our design now. We have the cogeneration part, which captures the waste heat, the turbine wheel, which spins, the side elbow, crankshaft supports, and inside the piston. Hello. Now you're all wondering, what is entropy? Well, let me tell you. Entropy is a measure of the unavailability of a system's energy to do work. It is a measure of the randomness of molecules in a system and is central to the second law of thermodynamics and the fundamental thermodynamic relation, which deals with the physical processes and whether they occur spontaneously. That is what entropy is.
Alright, so, in order for this machine to obey the first law of thermodynamics, energy must be conserved. As you can see, when the candle is on, it will be putting heat into our system. The heat will be transferred through the piston to do work by their turbine. However, there's still a lot of waste heat being produced through the top of the system and the engine. This tube collects that waste heat